So question 9, in this question, they want the molecular formula, which is actually defined in O-level as the total number of atoms present in one single molecule. This is one single molecule. So total up the number of atoms. There's 1 sulfur, there's 3 oxygen, there is 1 nitrogen, and there is 3 hydrogen. Okay, 1, 2, 3 there. Alright. So what's meant by the term acid? A substance that dissociates in water. So we talk about dissociation in water. So to have an acid, you need to have water. And what does it do? It give, or it form, or it produce H plus ions. Alright. Now, in terms of a weak acid and strong acid, is to do with the extent or the degree. Degree of what? The degree of ionization, meaning to say how much of H plus do you form, or you can talk about the degree of dissociation into the H plus. Alright. So weak acid only partially dissociates. So the word dissociates means break into, or we can say partially ionizes into H plus ions in solution, meaning to say in water. Okay, but a strong acid, this is basically just the definition really, okay? A strong acid dissociates fully or ionizes, so whichever word you like to use, ionizes or dissociates, but the key thing is really is about full dissociation into H plus ions, H plus ion in solution. Okay, so those are the 2 key points. The difference, all right, is to do with the degree of dissociation. It's strange that they're asking what is. That means they're looking for 1 point, but they give you 2 marks and quite a lot of lines. So the idea really is to talk about the partial dissociation versus the full dissociation or ionization into the H plus, which is very important. Okay. So now they tell you 1 mole of the sulfuric acid give you 1 mole of hydrogen ions. Hydrogen ions, yeah. So you can think of it like HCl. 1 mole of HCl give you 1 mole of H plus as well, right? So let's think about this. If I have HCl, when I react with magnesium, I will get MgCl2 and I'll get H2, and I'll need 2 of it. Okay. So now I put in this as sulfuric acid. Okay. Sulfuric acid just now was SO3NH3, SO3NH3. Okay. But basically, if I write out the proper structural formula, it will look like this. SO3H. Okay. So there's the NH2 there. There's the SO3, SO3H. Okay. So SO3NH3. So there's the molecular formula. SO3NH3. If I have 2 of them, so meaning to say the Cl, I replace it with SONH2. Okay. So what am I going to get? Because they tell you this specifically, right? So I'm going to get SONH2 twice plus H2 based on what we know about HCl. 1 mole of HCl give you 1 mole of hydrogen ions. I've done this example with HCl, so it's something I'm familiar with. So the H there, I take out 1 H such that the Cl can be replaced by SONH2. Then it's just give me that. Alright. So the equation looks weird because this is not an acid that you are familiar with. Alright. This is not an acid you are familiar with. That's why it looks really weird to you. Okay. But it's not different from if you know what this understanding is. Okay, I know you're familiar with HCl, that's why I choose HCl instead of something more complicated. All right, so that's the best way I can think about explaining this as simple as possible. Some stuff you won't get from your calculator, right? You need to think. It's an acid, it reacts with metal, so metal plus acid give you salt and hydrogen. You want to name, so you cannot use formula, unfortunately. Okay, but you know it'll give you H2, yeah. So they tell you the formula of the anion is that, so it's a -1 ion. You react it with Mg2 plus, because the magnesium get oxidized, because this is a metal plus acid, is an oxidation reaction, metal salt and the gas. The H plus become H2, that's reduction. I hope you know this equation from your electrolysis. Funny, right? You talk about things in electrolysis and then suddenly you talk about organic chemistry. Well, this is chemistry, okay? We'll come to the real world. This is plus 2, this is minus 1. The LCM is 2. 2 to get to 2 is 2 times 1, so it's just 1 magnesium. Alright? And then you have minus 1 to get to 2 is times 2, so you need 2 of that. CH3, SO3, 2. I'm pretty sure the way you learn balancing formula is like Mg and CH3SO3, and then you learn that it's like plus 2, and then it's minus 1, and then you do this cross thing where you get 1 and 2, then you get that Mg and CH3SO3, 2. Where does this thing come from? Why in the world do you do this cross multiply? Well, LCM, your primary school mathematics, lowest common multiple is 2. You need 2 of the minus 1 charge anion to balance out the plus 2 of the cation charge there. That is what this means, LCM. Alright? NO2 reacts with water to give you nitric and nitrous. Now you need to balance this equation. There's 1 nitrogen, but there's 2 nitrogen, 1 here and 1 here. So sensible to put a 2 there. 2 hydrogen, there's 1 there and 1 there, so hydrogen is balanced. Oxygen, there's 2 times 2, there's 4, plus 1, there's 5. There's 3 there, plus 2, there's 5. This equation is balanced now. Alright, you want to describe difference, strong acid, weak acid. So you do define each. You define each one, okay? So a strong acid dissociates, so the keyword really is dissociates fully into H plus in water. Alright, and then a weak acid, however, only dissociates partially into H plus in water. I have used the word dissociates. It means break into, okay? Some schools or some teachers would use the word ionizes into. They are the same meaning, okay? When you ionize things, you're actually breaking the bond into the ions anyway. So they're actually the same thing, alright? Blah, blah, blah. Okay, number 8 is organic chemistry. Molecular formula defined as the actual number of atoms in one single molecule. Altogether, you have 1 carbon atom. You have 1, 2, 3, 4. You have 4 hydrogen atom. You have 1 sulfur and you have 3 oxygen. Does it matter what order you put them in? Not really. You can write H4CSO3, whatever, okay? As long as the actual number of atoms in one single molecule are stated out. That is what molecular formula mean, yeah? Methane sulfuric acid is a stronger acid. Well, what is an acid and what is strong, okay? So, a stronger acid will mean that methane sulfonic acid, so I'm just using the exact example. So back in the days, they like to just ask you to define something, which is, straightforward. Now they want you to use definition in the context of the example. So you have to use example, because if you know what you're defining, then it should be no problem applying it to a situation where you explain your examples. That's what they want you to do. Do you know your definition, or are you just memorizing randomly? When you understand a definition, that means you can apply it to an example, alright? It will mean that that acid itself will dissociate, or does dissociate actually, dissociate into H plus to a greater extent. Greater extent mean much more, okay? You can talk about it dissociates much more into H plus, that's very important. Dissociate in water or in H2O compared to or in comparison to, or than ethanoic acid. I mean, it's just the use of a comparative term in English, okay? Compared to something, then something, you know, all right? So what's the difference between an aqueous acid and an aqueous alkali in terms of the ions present, all right? An aqueous acid will have more H plus than OH minus ions, okay? A base or an alkali, an aqueous alkali, will have more OH minus than H plus ions in water, sorry. What do I mean by that? I know what some people will say. Some people will say aqueous acid contain H plus. Aqueous alkali contain OH minus. Is that correct? What does aqueous mean? When you talk about electrolysis, when you see aqueous, what do you say straight away? You say H plus and OH minus, right? Where does the OH minus come from? It comes from aqueous. What is that? There's water, isn't it? Hey? So all this while, you have been saying that when you have water, you have H plus and OH minus. So do not go away and do the opposite thing, okay? So you learn that there because actually water contains both H plus and OH minus. Water has pH neutral, right? That's because the number of H plus balance out the number of OH minus. When you have an acid environment where the pH is lower than 7, you simply have more H plus than OH minus. And the other way around for an aqueous alkali, right? So I hope that makes sense to you. Okay, the next bit, magnesium will give you the Mg2 plus salt, and then the butanoic acid. The big difference with carboxylic acid is this is what you call a carboxylate. Do you notice there is a -1 charge after it donates the H plus? This is a +2. So that is the danger there. People just assume you balance out, but no, +2, -1. You need 2 of it. Okay, so there's going to be something you need to be very careful about. Magnesium plus C3H7, so they use that form. C3H7CO2H is going to give you not CH3. It's going to give you C3H7CO2, okay? 2 of it, and then magnesium. This one is this one with a minus. Is a -1 overall. 2 of it is -2 overall. 2 plus on the magnesium. So the charges balance. You also get hydrogen. Okay, whatever equation you write, even though they don't say, you got to balance equation, yeah? 2 of the acid, because 2 of that, so you need 2 of it. Now this is the hydrogen ions that get oxidized, they get reduced to form H2, which is hydrogen 0. 2 of it give you 2 of it. Alright, so that one is done. So now, one method of determining pH is using pH meter. What is another method to determine the pH of butanoic acid? So, I mean, you know, when something is acidic, you can tell by using an indicator. So you can use by whether you can use a litmus, such as a litmus. So this is acidic, by using blue litmus paper. Okay, acidic. So basically, butanoic acid is acidic. Butanoic acid will turn blue litmus red. You see that when you need to describe, basically you should mention what is the test and what is the test result for that 2 marks, yeah? So pretty straightforward there. Either that, or you can use a pH indicator, really. Sorry, not a pH indicator, a universal indicator, which will give you a similar color change of red as well as the final color to indicate that it is an acid. Next question. You react methanol with acid. The progress of this reaction, you can take small sample every hour, and then you work out the concentration of hydrochloric acid. HCl is a reactant. As HCl reacts, the concentration of HCl will go down. Every hour, you will expect the concentration of HCl to go down. If the reaction is completely complete, there will be no more HCl. If there's no more HCl, when you take out the small sample of the reaction mixture which contain no more HCl, then there will be no more HCl. Then how in the world do you work out the concentration of HCl then? Well, it said describe a practical method. You have done this maybe throughout every single experiment you've done in O-level perhaps. You should know about acid-base titration. That is one of the way to work out the exact concentration of hydrochloric acid, right? So it's quite exact. So they want you to essentially describe titration. What can I do here? I think it's best if I don't outline this for you, but you can go away and think about your titration procedure. So it said describe, so it's not just stating, and it said practical method. So you should have the apparatus you're going to use, things like burette or pipette, the volume, like what is going into the burette, what is going into the pipette, and then it says how can you determine the concentration. So you're going to describe about the endpoint as well, but you're mixing colorless and colorless, so you need to mention something about indicator. Without indicator, how can you tell what is the endpoint, right? Okay, from there then you should probably work out like an equation. So you can use things like NaOH. So this is from the sample of the reaction mixture. Then you can get NaCl plus H2O. So the thing is, if you have this one which is non-volume, non-concentration, and you know the volume from titration, and you have the balance equation 1 1 1 1, then you can find out the concentration of the HCl in reaction mixture, and you take out the HCl every hour. So you do this every hour. But just like when you do titration, do you just do it one time? Not really, no. Okay, you need to repeat titration until concordant. We call it concordant, or you get a consistent endpoint that are within something as per your O-level syllabus. There is a different requirement in A-level, but there's also a requirement in O-level, so I leave that to find that out for yourself, yeah? Which you should know, really. I mean, when do you stop at titration? Within what kind of value? Alright? The one that you put a tick on it.